Okay, so today's class we are looking at interior angle sum of polygons. We're also going to look at congruent triangles and similar triangles. And that will be all that we're looking at today. So let's start with the interior angle sum of polygons. So there is a formula we can use to calculate the interior angle sum. So interior angle, so all of the angles on the interior of a polygon, but we're looking at the sum of it. So adding up all of the angles of that polygon, the interior angles of a polygon. So the first method you could use is you could use a protractor and just measure each angle and then add them up to get the sum. But we do have this formula called the interior angle sum formula. It's 180, and then in brackets we have n minus 2. So we would use our BEDMAS. We would solve for our bracket first, and then we would multiply to 180. This n here represents the number of sides in the polygon. So let's take a look at our first example. So we have this polygon here. So let's count the sides. So let's start from here. So we have 1, 2, 3, 4, 5, 6, 7. So it's a 7-sided. So that therefore our n will equal to 7. A 7-sided figure, remember, is called a heptagon. So now let's calculate our interior angle sum. So I'm just going to call it IAS, representing interior angle sum. So 180 and n minus 2. And we know our number of sides is 7. So we end up with 7 minus 2 and 180 times 5. All right, so that means 900 degrees. So when we multiply 180 times 5, we get 900 degrees. That means all of the angles inside of this polygon added up together gives us 900 degrees. So if we have an octagon is 8-sided. So our IAS, interior angle sum, will be 180, and it would be 8 minus 2. So that would be 180 times 6. Okay, and that would give us 1080 degrees. 1080 degrees as the sum of all the interior angles in an octagon. If we were to do a nonagon, how many sides are in a nonagon? Then for nonagon, so same thing, interior angle sum, our IAS, so 180, and then it's 9 minus 2, which gives us 7. So 180 times 7. And for a nonagon, that's 1260 degrees. A rectangle we know has 4 sides, so it'd be 180, 4 minus 2, so 180 times 2, which is 360 degrees. All right, so that is the interior angle sum. Now, looking at what we already know when we have a triangle, we know that the interior angle sum of any triangle is always 180 degrees for any triangle. So another method you could use if you are looking at a polygon and you forget the interior angle sum formula, you can just divide the polygon into triangular regions. So we have this polygon here. Starting from this vertex, we've drawn 2 lines here, 1 and 2, and we've divided it now into 3 triangles. So we know one triangle is 180 degrees, so therefore 3 triangles would have an interior angle sum of 3 times 180 degrees. So 3 times 180 is 540 degrees. All right, and we can double check that with our formula, IAS, which is 180 n minus 2. Okay, so let's count how many sides this is. It's 1, 2, 3, 4, 5, so it's a pentagon. So 5 minus 2, and here we will also end up multiplying 180 times 3, which is equal to 540 degrees. All right, so we can use the method of splitting the polygon into triangles, as we did here, or you can use the formula that IAS equals 180, and then in brackets we have n minus 2. Is this the same? This is a 1, 2, 3, 4, 5, 6. This is a 6-sided polygon here. So it says to divide the polygon into triangular regions to determine the interior angle sum of each polygon, and then you can verify with the formula. So let's start with this. We'll start with this vertex here. So I can split this into 1, 2, 3 lines, which makes 4 triangles. 1, 2, 3, 4. There's 4 triangles here. So 4 times 180 degrees, which is 720. So that means the interior angle sum of this polygon is 720 degrees. And we can confirm that using our formula, which is 180 n minus 2, so 6 minus 2, which is 180 times 4, which is 720 degrees. So both methods work. You can split the polygon into triangles, or you can use the interior angle sum formula. All right, so next we're looking at congruency of triangles. If you remember, congruent means equal. In math, it's another term for equal. So if 2 triangles are the same size and the same shape, they will be congruent. So here we have a triangle XYZ and we have a triangle ABC. They are congruent because angle X here is equal to angle A, shown here. Angle Y is equal to angle C, which is shown right here. And then angle Z is equal to angle B, shown here. Now those 3 angles and those 3 angles here we can see are congruent. So we can also say that side XY is equal to side AC, all right, because of these 2 angles. So these 2 angles, side side XY is equal to side AC, side YZ is equal to side CB or BC, and then XZ is equal to AB. All right, so these 2 triangles are congruent. They're equal in size, they're equal angles, and equal sides. Now, mathematicians, they've determined that in order to prove that 2 angles are congruent, we don't have to show that all 3 sides and all 3 angles of one triangle are congruent to all 3 sides and all 3 angles of another triangle. There's 3 rules here. We can say that 2 triangles are congruent if the 3 sides of one triangle are congruent to 3 sides of another triangle. That's called side, 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 or SSS for short. So here the 3 sides are equal, so therefore we can say that these 2 triangles are congruent. Another way is if you have 2 sides and an angle in between. In one triangle and it's congruent to the 2 sides and an angle in between, then we can say that both those triangles are congruent. And so this rule is called side angle side, or SAS. And last one is the ASA, which is angle side angle. So similarly here, angle side angle. So therefore we can say these 2 triangles are congruent. All right, so these are the three that you can use. It has to be SSS, SAS, or ASA. So we have three pairs of triangles that we're looking at here, and we have to determine, are the triangles congruent? So if we look at our first one here, we have angle, side, angle, and on this triangle we have angle, side, angle. So ASA. All right, so the first pair of triangles, because it's ASA, we can say that yes, they are congruent. Let's take a look at our next one. So these two triangles here, we have angle, side, side. All right, if we have ASS, then no, not congruent. Let's take a look at our last example here. So we have a side, then we have an angle, and then we have a side that's being shared by both triangles. So here we have side, angle, side, side, angle, side. Okay, let's go back and check. SSS, SAS, or ASA. SAS means yes, it is congruent. So we're looking at these three triangles, and it tells us in the question, find the value of x in each pair of congruent triangles. So in the question, it already tells us that they are congruent, so we just need to determine the value of x. All right, so if we look at this, we know it's 40 degrees, we know this is what we're solving for, but because the two triangles are congruent, then we know this is also 30 degrees. So to solve for this, we just have to do our 180 minus 40 minus 30 to get angle x. All right, and we know that because all three angles in a triangle will always add up to 180 degrees. All right, so 180 minus 40 minus 30, that gives us 110 degrees. All right, our second example, sorry. This little square here, do you guys remember what that means? So 90 degrees, if you know two angles, you can easily solve for the third one. So angle x is 180 minus 90 minus 60, which gives us 30 degrees. All right, last one here. Again, if we know two angles, we can solve for the third one. So 180 minus 32 minus 110 gives us 38 degrees. So angle x, 180 minus 110 minus 32, which is 38 degrees. Angle x. Okay, so next we're going to look at what are similar triangles. Similar triangles, using just that squiggly line symbol. So triangles are said to be similar if the angles of one triangle are equal to the angles of another triangle, AAA. But the sides are obviously not the same. All right, so this angle is congruent to this angle. This angle is congruent to this one. This angle is congruent to this one. But yes, it's just smaller. This is larger. This is smaller. So therefore, the two triangles are similar. They are not congruent. All right, angles are congruent, but their sides are not the same size. So what we can do with questions like these is set up ratios. So whenever two angles are similar, the ratio of their corresponding sides are equal, like we can see here. So A over X is equal to B over Y is equal to C over Z. All right, make sure you keep your triangles organized. So if you look at all our top letters, they all corresponded to our larger triangle, and on the bottom, the letters corresponded to the smaller triangle. So if we know that two triangles are similar, we can use ratios to find the length of a missing side. So let's take a look at our example. So we're given two triangles and we're told that they're similar. I'm given that squiggle, which represents similar, and we have to find the length of side x. So side x is here. So what we do here is we're going to set up ratios. So we have our smaller triangle, which is ABC, and our larger triangle is DEF. So just make sure when we're setting up our ratios that they are organized correctly. So we know that side 16, which is AC, corresponds to X, which is DF. And the other sides that we know is BC here, which is 12, corresponds to this side here, EF, which is 36. And we've set up a ratio. And if you guys remember, when you set up a ratio, we can use our cross multiplication to solve for x. So x, we multiply, to solve for x, we multiply 16 times 36, and we divide by 12. So x is equal to 16 times 36, and then we're going to divide by 12. So you just got to put that into your calculator, and we get 48 meters. So just finishing up the first one here. I've already set up the ratio, so all we have to do next is cross multiply. So 9.2 times 12.4. And then we just divide by 36.8. And we get 3.1. And there's no units given here, so we would just say 3.1 units. Okay, and we have this one here. So similarly, we can set up our ratio. So 18 here corresponds with 30. So 18 over 30, and then x over 16. Okay, a common mistake students make is they'll mix up the ratio. So just keep in mind again the two triangles. So the 18 and the x on the top here are used from this triangle, and then the 30 and the 16 are from this triangle here. So 18 times 16, and then we're going to divide by 30, and we get 9.6. And again, there's no units given, so we'll just say 9.6 units. All right, so I'm going to pause right here